My name is Medhat Elmasry. Today I'm going to talk to you about using MySQL database in a Docker container with an ASP.NET Core 2.0 web app on your host computer. So essentially what I'm going to be doing is this. We're going to build at first one container that's going to contain a MySQL database. And we're going to access that MySQL database that's containerized. We're going to access it from an ASP.NET Core application that is running outside of the container. That's the first step. The second step is to containerize the ASP.NET application, and that will result in two containers. A container that hosts MySQL and another container that hosts the ASP.NET Core application. So I'm just going to do a diagram here of the first thing I want to do. The first thing I want to do is create a MySQL container. And I'm going to access that container from an ASP.NET Core application. Running outside of the container. And MySQL, it listens on port 3306. We're going to expose or map the port 3306 in the container to 3306 outside of the container. So this is what we're going to do at first. So let's get started. I'm going to go into a folder where I'm going to create an ASP.NET web app that I'm going to generate using the .NET utility. I'm going to call my folder ASP.NET Core MySQL. And in that folder, I'll drop into a command prompt. And in that command prompt, I'm going to scaffold an ASP.NET application that uses individual authentication. So the command for that is .NET new MVC --auth, and we want to use individual authentication. This will generate for us an application that uses SQLite as the backend database. If I want to run this app, I can go .NET and run. Now that this message came up, it says it's listening on port 5000. Let's open up a browser and go to localhost 5000. And here's our website. I'll close the browser here. And the first thing I want to do is to point my application to work with MySQL rather than SQLite. So I'm going to hit Control-C here to shut down the web server. And let me open up my application in Visual Studio Code. You can open up the files that we're going to change in any editor you like. I have Visual Studio Code, so I'm going to type in code dot so that it opens up this folder in Visual Studio Code. So the first thing we want to do is install a driver that will allow us to talk to MySQL. So we're going to go into a command prompt inside of Visual Studio Code, and that is done by hitting Control backtack. When you hit Control Backtrack, you get a terminal window, and in here you can enter terminal commands. I'm going to execute this command here, .NET add package pomelo.entityframework.mysql, and this will install for us the appropriate package. I'm going to copy this and paste it down here. And there goes, it has installed it for us. And in our ASP.NET Core MySQL CS proj file, you can see that it added this package to our application. The next step is to replace SQLite in our application with MySQL. So where's that setup? Let's go to the startup file. In the startup file, you can see in the configure services method that we are using SQLite. We don't want to use SQLite. In this application, I want to use MySQL. So let us comment out this code, and I'll replace it with the code that we'll be using for MySQL. I will paste the following code here. This code would be using MySQL instead of SQLite, and we are setting up essentially the connection string right in here. The reason it's better to use this kind of way to set up the connection string is because with containers, you want to pass these configuration values as environment variables. So what this is saying is, if the host is available in the configuration environment, then take that, otherwise use localhost. If the port number is available as an environment variable, use that, otherwise use the default value of MySQL, which is 3306. If the password is being passed as an environment variable, use that, otherwise use this very, very secure password. This is the connection string that's being set up. The server will take on the value of DB host. The root password will be taken from the DB password environment variable, and the user ID will be always root. Of course, this is not something you do in production. And the port number again will be taken from the environment variable. And we're going to create a database called products. We can call it what we like, but I'm calling it products here. The next thing I want to do is, this application involves entity framework migration. Because this will eventually be running in a container, I don't want to go into that container and say .NET EF update database or add migrations. All these commands, I don't want to do them. I want to do them programmatically in the application. Therefore, I will add a migration command inside of my startup. And to do that, I would put it in the configure method. But the configure method needs to have a handle to the context object. So I'm going to pass that in the configure method using dependency injection. So I'm going to add another argument to the configure method, which is the application DB context. And I'll just call that context. This happens to be the main DB context of our application. And we know that by going to the data folder and opening this up. This is the main DB context, as you can see here. So I'm passing that as an argument to my configure method using dependency injection. And down here, right before use MVC, I'm going to go context dot database dot migrate. And this essentially does the migration programmatically. Let's go into a terminal window at this location. So here I am in the main folder of my project. I'm going to do a .NET restore, a .NET build, just to make sure that everything compiles properly and I don't have any errors. Now, if I run this application, obviously it's going to crash. I told it to use MySQL, and there is no MySQL for it to use. I'm going to grab MySQL from Docker Hub, download the image, and run MySQL as a container, and have my application work with it. And it goes back to this diagram. I have done this piece here, but I haven't done this piece. I don't have this piece. I need to get MySQL running in a container. So how do we do that? Okay. So I'm going to run this command in a terminal window. This one basically says, go get me this image from Docker Hub. And after you've brought it, run it in a container. Expose internal port 3306 on the host machine as 3306. Name the container MySQL DB and pass this environment variable, MySQL root password. I do not really need to do this because the default password is secret anyways. But I'm just doing that so that you get a sense of how do you pass environment variables into the container. So let's take this and run it. At this point, it should be running. I did not need to bring down the MySQL image because I already had it. And in order to save time, I pre-downloaded it. Now let's find out what are the containers that are running here. And the command for that is docker ps -a. And you can see that we have this MySQL container running. This is the name of the image, and this is the name I gave the container, MySQL DB. Of course, the proof of the pudding is to run the application and see whether or not it's able to communicate with MySQL that's running in the container. To do that, we can just go .NET run. Our application is listening on port 5000. Let's check it out. Sure enough, it has started. But the real proof for us is to register some data in the database. So we're going to click on the register button here, and let's register a user. And sure enough, you can see here that a user has been registered. This proves to us that our ASP.NET Core application is indeed talking to MySQL, which is containerized. Let's take this another step. How about we containerize our application too? So I'm going to close the browser, shut the web server down, and stop and remove my container. So to find out what containers are running, I can go docker ps-a. And you can see that this container is running, and it started about 3 minutes ago. Let me stop it. So I go docker stop, and I can take enough characters from the ID that is unique enough to stop it. So I'm going to just use 40. I could also stop it by the actual container name. I could also type in MySQL DB. That will work too. Now I stopped it. Let's look at docker ps-a again. And you can see that down here it says it exited 8 seconds ago. I want to remove it. So I'm going to recall this command, the stop command, and replace the word stop with rm. This will remove the container. If I go docker ps-a, I don't have any container. Now let's go back to our diagram. What I want to do now is to create another container. I want to containerize my ASP.NET app. So it's going to look something like this. And we'll have to expose the port number of our web app to the host machine. And the port number of our web app is going to be 80. And I'm going to expose it to the host machine as 8888. So this is the next step we want to do now. So both our database server and our web application will be containerized. Now, when you containerize an application, typically you want to containerize the release version of that application. There is a .NET command called publish that produces the artifacts that are the release artifacts of your application. The command I'm going to use is .NET publish, and I'm going to use the switch -o dist, which means publish for me the release artifacts into the dist folder. So if I hit enter here, it will restore, build, and put the release version of the application into my dist folder. This is done. Let me go and have a look at my dist folder. And sure enough, here is my dist folder, and it's got my artifacts. The main application is a DLL, and it is this one. This is the main DLL. That is the entry point into my application. If you want to run it, you can go to that directory, the dist directory, and you can do a .NET and run that main DLL, which is this one here. If you do this, your application will run. But of course, if I try that now, it probably won't run. Why? Because I killed the database container, and when this application tries to run, it won't know how to connect to a database. But let's try it. So it is complaining. It's complaining that unable to connect to any of the specified MySQL hosts. This is understandable. But if we're not connecting to a database, this would have run. So let's stop, go back to the parent folder, and let's get it to be containerized. In our application, we're going to create a text file called Dockerfile. In the root of our application, we're going to create a text file called Dockerfile. And in that Dockerfile, we're going to create the code that is needed to produce an image of our application. This is the code for our Dockerfile. What we're saying here is build for us an image that uses this image as a base. So it's going to go and get that image if it doesn't have it from Docker Hub, and then copy the contents of my dist folder into the app folder of the container. Here's my dist folder. It's going to copy all this stuff into the containers app folder. Here we're saying the working directory or the main directory in the container is going to be app and expose port 80. To run my application, use this command, .NET ASP core MySQL. Now, I have to make sure that this is exactly the correct name of my application. And I shall do that by going into the folder of my application and making sure that the name I'm using for my application is the same. And the real way to do that is actually to go into the dist folder and grab the name of my application and paste it here. This is the app that's going to be run using the .NET utility. So this is my Docker file. The next thing I want to do is create a Docker Compose file. What's the difference between a Docker file and a Docker Compose file? The Docker is the instruction for producing a specific image file. Docker Compose is used for orchestrating an entire solution. And the orchestration of an entire solution means that we need a container for MySQL, we need a container for the web application, and we want both of them to talk to each other. So you need a Docker Compose for that. It's at a higher level. So I'm going to create a file called Docker Compose at this level here. So you can call it docker-compose.yml. YML is a special format that uses the parent-child relationship with indentations. And the indentations have to be spaces and not tabs. So the contents of my Docker Compose will be this. Here's my Docker Compose. It consists of the following. At the very top, you have to specify the version of Docker Compose that you are going to be using. As we speak, the latest version is version 3. Here I'm specifying the volumes that I want to use. I want to use a data file volume. In other words, I want to use a volume named data files. And the purpose of this is because I want my data to reside outside of MySQL. So that if, for whatever reason, the MySQL container is removed or deleted or destroyed, my data is not lost because it doesn't reside inside the container. It's outside the container. I can recover it by spawning another instance of a MySQL container. Now, I would be having two services, and a service represents a container. I want to have a service called DB, and this represents the MySQL database. It's going to be based on the MySQL image version 8.0.0 that would be downloaded from Docker Hub if it's not available locally. And this folder in the image will be mapped to my data files volume. This command, restart always, essentially means that if the container is stopped for whatever reason, it's going to be automatically restarted. The environment variable that I want to pass from the host machine into the container is this environment variable that has to do only with the password. I want the password to be secret. The other container will be my ASP.NET MVC app that has the image definition right here. This is the image definition for that container. So what does this say? It says when you build this image, use the current directory as the context and use this Docker file that I created before. Actually, if you look back at here, I call this Dockerfile, and down here I've called it Dockerfile MVC, so I'm going to delete this word .mvc. They have to be compatible. This image depends on the database, which means that if the database image is not available as a container, then my ASP.NET app cannot work. Here I'm exposing port 80 internal into the container to 8888 to the host machine. And if this container is stopped, it's going to be restarted automatically. And here are some environment variables that I want to pass on into this MVC container. One is I want the DB host to be DB. Let's go back to our code here. In startup, if you remember, down here we said DB host. DB host, when we were developing, it's localhost, but I want that to be overwritten with this DB. What does it mean? It means that go to this container here and you'll find the database. Finally, another environment variable is ASP.NET Core Environment Development. This is so that I can see any errors if they do happen. I'll get details of those errors. In production, you have to change this to ASP.NET Core Environment equals production so that no errors are displayed. Let's go back to this diagram. One thing that we have totally forgot about is that Docker actually creates a local area network here. This is a virtual network that contains both of these containers and allows them to talk to each other. The machine name of this container is going to be called DB. And the machine name of this container is going to be MVC. The ASP.NET Core 2 app, it can ping DB. If it goes ping DB, it's going to find DB. That's why here I said that the host is DB, because this is a known machine name in that virtual network. The final thing now is to run this Docker Compose file. And to run that Docker Compose, this is the command we're going to do. Docker-compose. And the file name is docker-compose.yml. This is the file name we gave to our Docker Compose file. And then I simply will say app. App means create this environment and start it. Let's see what's going to happen.
In the root folder?
We will be getting some errors here. As you can see, these are some errors that are being generated by our application. And the reason these errors are being generated is because the MySQL database hasn't started and is not ready by the time that my ASP.NET Core app wants to use it. This could generate some errors. It is possible to write some code inside of our Docker Compose so that we have it wait until MySQL is fully running. Now let's go into a terminal window and see what the situation is. So we can go docker ps-a. And you can see that both servers are up and running. Let's find out if this is working. Again, we can go into localhost 8888. And here's our application, it's running. Let's register a user. And sure enough, our user is registered. Now, we registered a user before, but we destroyed that database. So this is an absolutely new database that's running in a different environment. And it's working. I hope this video is useful to you. And I hope you take this further and make much bigger and better applications than this one. Thank you.